Hello, Keith Rucker here at VintageMachinery.org. Guys, today back to working over here on the Lucas horizontal boring mill. And like I've been telling you guys in a couple of videos, we're just trying to do some just cleaning up to this machine, getting it cosmetically looking good and getting it put back together so that I can use it for some upcoming projects. Now, long term, I'd really like to rebuild this machine and re-scrape everything in, get the spindle ground and uniform, put new sleeves, bearings up inside the head, and really get this thing tricked out and running really nice. It's an old machine. I think it was made in 1918, I think was the date, if I remember right. So I mean, it's over 100 years old, but really it's not in terrible condition for that age of a machine. But there's definitely been a few little issues that we have had to deal with along the way. So today, what my goal is I want to get this machine leveled up. I want to get it on some leveling feet. I've got these right here. I bought these, actually I bought a bunch of these when I was working on my metal planer. And what these do is you just got a little screw in here. These two pieces on the front are wedges, and you slide that piece forward and it raises this up and down. So it allows you to kind of do a precision leveling in some strategic places on this machine. Now, the way this machine is set up, it's actually on 3 points. So there's 2 anchor points on the back side, and there's 1 anchor point in the center of the bed up on the front. And that was originally where it was designed to do your leveling and stuff from. You would either use a leveling foot like this or just use shims or whatever, and I typically would bolt it down. Now, normally they would probably grout the machine in once it was leveled. They literally put like a concrete grout up underneath it just to kind of give it some more support, but really most of your weight is bearing on those 3 points. And the nice thing about 3 points when you're leveling is it's really easy to level something. It's easier to level something on 3 points than it is on 4 or more points, because you can really control things. It's like a tripod, and it's very stable sitting on the floor that way. We're going to be supporting this machine in 3 points, and I got another issue that kind of relates to that, in that I need to kind of get this machine up off the floor about, I don't know, it's probably a good 6 inches from where that normally would sit on the floor. And the reason is that you've got this shaft over here. So basically there's a shaft that goes down through there. There's a bevel gear that shaft slides up and down. It's a keyed shaft that goes up and down. And as you raise and lower this head, this is the power takeoff from the machine that powers things. And of course, this shaft is fixed in the head, but when it goes down, that shaft drops out of the bottom of the machine. And normally, or the way this machine would have originally been, you know, back in the day when this thing was built, they really weren't putting these machines on concrete floors. They typically were on wooden floors. You just drill a hole in the floor and the shaft would drop down to the floor. When I purchased this machine, the person that I purchased it from in Louisiana, he actually cut a hole in his concrete floor and dropped a piece of pipe down in there for that thing to drop down into. He even provided me with a piece to do that. But honestly, guys, I really don't want to have to drill a hole in my concrete floor. I mean, I could do it. It wouldn't be that big of a deal, but I would just rather not do that. And I got to do looking at the measurements. I've only got to get it up off the floor about 6 inches for everything to clear and everything to be fine. So I think we're just going to raise it up. So on top of these leveling feet, I mean, that's already getting us up probably, you know, 2.5, 3 inches. I've got some square tubing that we're going to put on top of this to kind of raise it up a little bit higher. And then we'll have a bolt that goes all the way down through these so that everything is firmly attached, and then we can level off those 3 points and get it all raised up simultaneously. So let's get in here and get these leveling feet installed. Once that is done, I also want to come in here and do a little bit of inspection on this bed and get an idea for how much wear is in it. And I told you guys before, while my long-term goal is to rebuild this machine, get all that re-scraped in, it's not something that I have time to do right now because I need to put this machine to work, and I know that it's capable of doing the work that I need for it to do. Again, long term, I would like to rebuild it. But since I have the table off of it and I got access to that entire bed, now's a good time to go ahead and just do a quick inspection and get an idea for how good or how bad things are, so that I just have a better game plan going down the road. It's not going to take a whole lot of time to do that, and I'd rather go ahead and just know what kind of wear is in that bed. I suspect it's going to have a fair amount in it, but we don't know until we check it. So we're going to check it and see. All right, enough talking. Let's get these leveling feet on, and we will get this machine leveled up and do an inspection on the bed. So we're down here on the floor, and you can see what we got going on. Right now, we got sitting up on a couple of 4x4s. I think I said 6 inches a while ago is how high we need to raise this. Really about like 8, maybe 7.5. Those blocks aren't quite 4 inches square, but still you see where we need to be. It's sitting right now where the shaft will go down. You can kind of see the shaft back here behind it. And when it comes all the way down right now, there's about 1 inch between the bottom of that shaft and the floor, which is just right. So we are going to, here again, we got our blocks here. This is our leveling piece, and I've got a piece of tubing on top of this. I've got a piece of thick wall tubing on the inside that bolt runs through just to kind of give some support right in the middle. And we're going to clamp it down. So there's a hole here. The bolt will go through all of this down into that leveling foot, and it will tighten down. So it will be attached. It's not going to just slide out or slip out or something. Also, I've got a piece of 8-inch diameter steel, piece of plate steel, probably, I don't know, 1/4 inch, 3/16, something like that, thick on the bottom. And the idea there is to spread the weight out a little bit more. So with that 8-inch diameter, it's about 50 square inches of contact that we're spreading the weight out on this over the 3 points. So let's go ahead. I'm going to jack this thing up, and we'll drop that in. So let me we'll move that over there. I'm going to put my jack right here. I've just got a toe jack, and we'll pick this up enough to get that leveling foot up underneath it. All right, here we go up. This whole assembly is just a little bit higher than the what we got in there now. We're going to pull this bolt out. I'll slide up under it. A little bit more. There we go. And I like that. We are going to drop that down on there. And I'm going to do this in the other 3 places. We'll tighten this up. It's not going to slip out right there. I've got 3 more points. One is directly behind this one in the back. And then on the very end, we got a single point. So we'll get that done. There we go. I like it. So the next big step is I want to check these ways here to see how much wear is in them. And I can see a fair amount of scoring, particularly kind of right here in the middle, which is where you'd expect it to be. It's kind of in the middle of the travel. Interestingly, I've already stoned this front one, and you can still see scrape marks into about back in here. Not surprised, because that's the least wear on this machine. Once you get up in here, can't really see them anymore, so we'll see. What I'm doing is I'm just taking a couple of precision ground flat stones, And I'm just going to take a few minutes here, and I'm going to try to get all the high spots and dings and the scoring marks, kind of get it all flattened back out and level with these stones. So you're just kind of knocking off high spots. We're going to be taking some precision measurements here in a little bit, and a little burr on this can make a big difference. We're not removing a lot of metal here, guys. All I'm really doing is just knocking off any high spots, any burrs, and like I said, there is some scoring in this table or in these waves, and you would expect to have a little raised area next to that, and I can see it coming off. It's polishing up from side to side pretty good here, but just to give us a more accurate reading on things. So I don't know how well this is going to show up on camera, but we're down the very end of the table on the front side of the machine, and you can kind of see up underneath the bottom of this the scrape marks that are in there going in a couple directions. You know, are those original to the machine? Are those, you know, somebody that came in after the fact and just scraped it for oil retention? I don't know. My guess, though, is this is probably original to the machine. Being out here on this end, you can't really see them where most of the wear is. So another cool thing that I noticed is that, you know, when I stone this bed, anything that's high kind of gets polished. Anything that's low is not polished. And you can kind of see the bed looks striped. And these run the entire length of the bed. And what those are the planer marks where this machine was planed on a metal planer. It was not done with a surface grinder. It would have been done with a single point flat tool and just gone across there. And more than likely, you know, when this machine was made in 1918, that was standard practice. And the planer will get something very, very flat if done properly. And I'm sure that these guys were doing things just right. But you can see those planer marks, real interesting. You know, we're probably only talking 0.010 of an inch high, you know, differences in height between the top and the bottom of those valleys. But still there nonetheless. And the good news is that I can see those from end to end, and you know, the width of these little stripes appear to be pretty uniform, which again is a good sign that we may not have as much wear in this bed as I was thinking we may have. We'll see. But I would expect that if it was worn real bad, that you would see these stripes widen out and maybe even just come a solid plane. But because I can see them all the way down, anyway, that's kind of a promising sight that this table may not be in that bad a shape. All right, let's do some inspecting on it and actually see where we're at. Let's get it leveled first, though. So now we're going to begin the leveling process. And to do this, I've got out some of my precision levels. Now, when you're leveling a machine, you don't use just any old regular level. You know, a carpenter's level, not accurate enough. Even what's considered a machinist level is really not accurate enough to do a great job of leveling machine. Yeah, you can get it pretty close. You can get it, you know, more or less level, but to really get one fine-tuned and accurate, you need a precision level. And just to kind of give you an idea of the difference, what we're talking about, a machinist level like a stair at 98 is going to be, I think it's 5 thousandths per foot. So every line on the bubble reads 5 thousandths increase in height over one and the other over a 1 foot difference. A master precision level like the stair at 199 here, it reads a 0.5 thousandth per foot. So instead of 5 thousandths moving the bubble one line, 0.5 thousandth per foot would do the same thing. So you can do this, and most people will use the precision levels to do this with. And to do it, you either need 2 levels, or you can do it with one, but you have to turn it 90 degrees. So you have to get it level from end to end, and you have to give it leveled from front to back. And so you have to turn it 90 degrees to get it in both directions. Not a big deal. A lot of people just do it with one level. That's the nice thing with me on this machine, because we're leveling it on 3 points. You know, if the tail end's down, you just got 1 point to raise up, and you got 2 points on this side, so I can easily adjust it front to back, but it's just going to pivot on the one up front. on the end rather. So the 3-point leveling really makes it a lot easier than if you have multiple points. Now, when I'm leveling machine, I like to use this level here. This is called a fell all-way precision level. It also reads in a 1/2 thousandth per foot, and I'll let you look at this in a minute. But instead of having a single bubble, it's kind of got a bullseye in there. It's a round bubble, and you're trying to get it centered up into the center so you can really see everything going on in one easy view. You know, when I look at this one, I can tell that this end is down, needs to raise up. And then, you know, I'd have to turn it, and yeah, that one will bridge across there. Probably really need to get a parallel to put it on, but I can also see that I need to raise it up in the back to get it level in that direction. The nice thing is with this level is I can see all of that in one place. Let me show you what this looks like. Got you guys looking straight down on this fell level. And again, it tells you the same thing. You know, this end is high. We need to raise it up on this end over here to move the bubble over. And also this end over here is high. We need to raise this end up to move the bubble up this way because it's kind of down in this corner, so it tells me it's off in both axes. So we're just going to make some adjustments to these leveling feet and see if we can't get this thing dialed in. I will tell you this thing is super, super fussy. If you breathe on it wrong, it'll move this thing because it is so accurate. I mean, 1/2 thousandth per foot. So basically 1/2 thousandth of an inch from one end of this level to the other. We'll move that one line on there. And to give you an idea, you know, human hair is about 3 thousandths. So, you know, that's 1/6 the diameter of a human hair on every single one of those lines. So extremely, extremely fussy. So let me get some wrenches and we will start making some adjustments. Again, I know that the back end needs to raise up, or this end needs to raise up, and this end needs to raise up. So we're going to really be cranking on the 2 leveling feet on the end. I need to bring them both up a little bit and the back one up a little bit more than the front one. And we'll be keeping an eye on the level while we're doing that. Now to adjust these leveling feet, there's just a screw in there. Again, there's 2 wedges that have angles on them. And I've got it basically all the way down right now. I want to pull this screw toward me, and that's going to raise this up ever so slightly. There is a screw right here, and when we turn that, it's going to slowly lift that up ever so slightly with every turn of that handle. So I want to be kind of up and down, up and down. This goes a lot easier if you have someone helping you that can watch the level. I don't have that right now, so I'm just going to have to jump up and down. But anyway, we're going to make an adjustment. Let me go check the level and back and forth until we get it right. I'll do this and bring you guys back in a minute. All right, guys, we're getting really close here. And I'm going to let you kind of watch as we fine tune this in. I'm just lowering the back corner back there a little bit. And I'm going to lower the front corner. And it's just going to be easing ourselves into this. We're within probably 1,000th per foot right now. I'm going to lower the backside again. Now the front side again. Easing it in there. Go to the back side again. on the front side. Guys, I think I'm gonna call that good enough. I may try to fine tune this a little bit later on. Well, it's easing forward a little bit now. I'm within a half a thou per foot. But for my testing that I'm about to do, this is gonna be good enough. And I think what I'm gonna do is just leave this alone, and we'll fine tune this later on after we've made some other adjustments, because it'll probably need some further adjustments. But part of it, I just want things to kind of settle in on these leveling feet. I'm probably going to have to come back in a couple of days and check it anyway, because the concrete's going to settle in some things like that anyway. But with this is really close, and for what I'm about to do is close enough. So next step here is I want to start my inspection process and really kind of seeing how these ways relate to one another, and see how much out they are. And we're going to do a couple of different tests. The first test I'm going to do is I'm using my Kingway alignment tool, and basically what I want to do is I want to see how this way compares to this way. And basically what we got here is this tool rests on the front edge of this way, and we're going to slide it down, and we've got a cross arm going back to the other way. Now up in the top here, we've got a precision level, very similar to the levels that we were just using a while ago to level the machine with, although this one's even a little bit more accurate than the ones we were leveling with. The ones we were leveling with were half a thousandth or 5/10,000ths of an inch per foot is what the measurements for each increment on this line. So on this one here, this level is actually reading 3/10,000ths per increment. So it's not quite half or twice as the resolution as the other one. So, and what we're going to do is I'm just going to go down through here, and I'm just going to start. We're going to call a line 0, and we're going to go plus or minus off of that line, and we're just going to move it down about the length of the piece here at a time. We'll let the level set, we'll read it, and we're going to write those numbers down on the ways. And again, what this is doing is this is telling me the difference in height from the front way to the back way. So we're just going to go all the way down through here and read those off. So I'll tell you what, let's go back up to the start, and I've already kind of got my level zeroed out, and we're just going to call this one 0, and I'm going to put my number right here kind of in the middle of where we're at. I'm just going to write it right on the ways. And again, what we're going to do is we're going to move this down about the length of this back piece. We're going to let this settle out, and I'm going to do some estimating here. Basically each line is 3/10,000ths. I'm going to kind of estimate the 10,000ths in there, and this looks like it's moved maybe 1/10,000th. So I'm just going to call this a 1. And we're going to move it down again. Let that settle out again. It moved again, just the same amount. I'm going to call this a 2. And we're going to go all the way down the machine, doing just exactly this. So let's give an update of where we're at here. I have done some inspecting on this machine. I've actually done a lot of it kind of off camera, and I'm kind of catching you guys up here. It's actually the next day now. I decided I wanted to let this machine kind of sit at least overnight, to make sure that everything kind of settled out before I did any real precision measurements. Now, I'm a little bit surprised with what I found. Not really good, bad, or indifferent, just it wasn't what I was expecting. I was really expecting most of the wear to be kind of in here, and I was expecting to see this thing kind of drop down in here and then raise back up as it went down. Instead, when we come from one end to the other, just sliding it down about 8 inches at a time, getting different readings, it's just gradually dropping down on this front side from the very end down here to this end. And honestly, it really doesn't start dropping off really bad until you get down here towards the end of the machine. Now, according to this measurements, from one end to the other, over the entire length, this side is about 3.5 thousandths of an inch lower than it is on the front, at least comparative to the two ways. So again, to kind of give you an idea, that's about the diameter of a human hair. So not a lot, but for a precision machine tool, we would want it to be less than that. I think the spec, you know, on a brand spanking new machine, everything just really tuned in just right, is going to be, what is it, a half a thou per, no, excuse me, 1/10,000th per foot. So over basically 8 feet, which is the length of this bed, you're looking at what, 7/8 tenths. So, you know, 3/4 of a thousandth of an inch. We're about 3 times that much. Now, is that terrible? That's actually a lot better than what I was expecting it to be. I was expecting to see a lot more difference in there than what we're seeing. And in the grand scheme of things, for the type of work that I'm going to be doing on this machine, it's not going to make a big difference. Now, keep in mind, twisting the bed by 3.5 thousandths doesn't mean that if I'm boring something, it's going to be out 3.5 thousandths of an inch over here. It's probably going to be, you know, mathematically some small fraction of that, depending on the directions and a lot of other variables going on. But that's actually very livable. I'm pretty happy with that. So I did one other test. I wanted to kind of look and see, you know, how flat these ways are from one end to the other. Again, I mean, I can look at the bed and tell that in this area right in here, there's a lot of wear. That's where the table spends most of its time running, kind of like on a lathe. You have an area on that lathe where most of your work is done. And that's exactly the same thing that's going on here. And you can see it. There's some scarring and gouging in there. I mean, it's not terrible, but you can see it in the bed. And that's exactly what we saw. Let me show you how I measured that. Let me move this Kingway out of the way. So to check the flatness from one end to the other, I'm using a big straight edge. Now, if you guys have seen me do scraping videos, you've probably seen me use straight edges in the past. Basically, the straight edge is taken to a surface plate or something that's a known flat surface, and you'll glue it up and check it and make sure that it's a match to your reference plate. Now, this is an 8-foot long straight edge, and my plate that I have is only a 6-foot long plate. I have checked this as well as I could, and it's in pretty good shape. I'm not going to say it's perfect because I really need an 8-foot long surface plate to truly check it and scrape it in just right. But when we did inspect this, when I got it, it's in very good shape. So I'm very confident that it's given us good measurements. And when you're scraping, what you would do is you would actually glue this up and then come over here and you would move that on your ways, and that would tell you what's high and low and tell you what you need to scrape away to actually scrape a machine in. But what I'm going to use it for here is a little bit different. I'm just going to look and see how much of a dip that there is in this table. Again, I know there's a dip in it. I can see the wear right in here. And so what I've done is I've got this on here. It's just sitting across theoretically, and I already know this because I've checked it, but this is touching on the ends. For my second test that I'm going to do for this inspection that I'm doing is I want to see how flat these ways are. We've looked at the twist. Now I want to see, you know, how much variation there is up and down going along the length of them on both sides. And to do that, I'm going to use this Camelback straight edge. This is an 8-foot long straight edge that I have in my collection. I picked this up a couple of years ago. It's actually the first time I've ever used it. This thing's really heavy. Thankfully, I have the gantry crane in here to pick it up and help manipulate it. I've got it loose. It's not tight. It's sitting on the casting right now. And for those that are not familiar with these straight edges are calibrated on a surface plate. Your surface plate should be calibrated to see that it is extremely flat. My surface plate is flat to within, it's basically a grade A right now. It's very close to being a grade AA. I need to do a little bit more lapping on it, but extremely flat. I'm talking about millionths of an inch in differences from the high spot to the low spot. And I checked this straight edge out as best as I could. My surface plate is only 6 feet long. This straight edge is 8 feet long, so we had to kind of shift it down. It checked out pretty darn good. I haven't done any scraping on it or anything, but it is a good standard for me to use. I know that it's, you know, at least flat within probably a 10,000th of an inch from one end to the other. That's me guessing, but that's going to be a really close estimation. So what I'm doing here, normally when I'm using these is when I'm scraping, and I'll blue this up just like I would blue up a surface plate, and I transfer this over to the machine, and I use it to blue the high spots up for scraping. We're not scraping right now, we're inspecting. So what I'm going to do instead is I'm going to use a feeler gauge. A feeler gauge, this has basically a bunch of different leaves in it. They're all different thicknesses. These are in 1,000th of an inch increments for the most part. There are a couple of 0.5 there as well on the smaller sizes. And all I'm going to do is I'm going to go down this straight edge and see where this feeler gauge will go in. And see right there, it's moving in. I got a 5,000th inch feeler gauge in there right now. And I just start with something and check it in different places. And by that, I can go in here and map it. And again, I went in and just wrote on the table with a Sharpie pen what size feeler gauge will fit within different ranges down through here. And here's what I found. On the front edge of the machine here, like I just said here, I got a 5,000th. That was the maximum. That was the largest size that I could fit in there anywhere. And there's an area from about, where's it, from about right here to right here that a 5,000th will fit in. And then it goes to a 4,000th, to a 3,000th, a 2,000th, 1,000th, and then I couldn't even fit a 1,000th in here. Going from the other side, this is where my greatest area of wear is. It goes to 4,000ths, 3,000ths, 2,000ths, 1,000ths, and that's all less than 1,000. On the back side, very similar to what I saw on the front side, but the wear isn't as great back there. The largest one I could put in there was 3,000ths of an inch. So bottom line, again, I'm pleasantly surprised. Yes, 5,000ths. In a precision machine tool, that is a lot more than what I want to see. But the truth of the matter is because of the way that this saddle rides on this, you're probably never going to be totally in that 5,000ths area. It's probably going to be somewhere in between because you got different points of contact, you know, a wide area. Again, just like on the twist, just because it has a 5,000ths dip in the table here, 3,000ths in the back, doesn't necessarily mean that my work is dropping that much, again, because we have multiple points of contact. So this is exaggerated over the maximum error. It's not where I would ideally like for it to be, but it's not terrible either. Again, much better than expected. So again, pleasantly surprised. I would eventually like to get this thing straightened out and get it really tuned in good, but that's not a job for today. Right now, I just want to take a quick peek and see how it looks. And again, I'm pleasantly surprised. So I think that we can use this machine just like it is with no problem. It's not going to be perfect, but it's going to be close enough for most of the work that I'm going to be doing. So I'm real happy with that. Well, there you go, guys. A very quick and dirty, quick inspection of the ways on this machine. Again, by no means a comprehensive evaluation of everything wrong with this, just kind of taking a picture of that one part. But again, I wanted to take the opportunity to do it while I had things taken apart. I really honestly thought for a 100-year-old machine that it was going to be a lot worse than what it is. So, you know, maybe one day we'll do a total rebuild on this machine. I think it'd be a cool project. I think it'd be a lot of fun. Be a lot of work, but a lot of fun. Be a challenge, a mental challenge with all the geometry going on here. But that's the kind of thing I like to do and kind of like to learn and like to share. So, you know, maybe we'll do that one day. We'll see. But for right now, we're going to put it back together. We're going to put this machine to use. Like I said, I got a project coming up I need to use it on. So up next is we're going to get the table that we took off of this and go ahead and get it put back on. Possibly go ahead and tear it down the rest of the way just to kind of make sure everything is like it should be, and then put it back together and kind of, again, not rebuilding it, not re-scraping, doing all that stuff, but just making sure there's nothing major wrong with it, and get it up and going. So there we go. Guys, with that, that'll be a wrap. As always, thank you so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. Hit the bell icon to get notifications when new videos are posted. And big, huge thank you to all the supporters of the site out there who help me out with Patreon and through other means as well. Many of you guys, you know who you are, and I greatly appreciate everything you do. And with that, guys, we're going to sign off. As always, thanks for watching.